greet our respect, ladies and gentlemen. Allow me to cordially welcome and greet our respectable excellencies, guests, and speakers. Attaché of Education and Culture in Indonesian Embassy in Canberra, Professor Dr. Yuli Rahmawati, PhD. Professor in Water Resources and Environment Universitas Gadjah Mada, Dean of School of Vocational and Applied Science, Professor Dr. Engineer Agus Mariono, IPM, Distinguished Professor Water, Environment and Sustainability, Western Sydney University, Australia, Professor Basan Maheswari. A very good morning to every one of you. Welcome to the Science Tech series with the theme of fostering impactful research and innovation in energy and water resilience. Let me introduce myself. My name is Sarina Hanifa, and I will be your host for the day. So it's such a great pleasure to meet you all. First of all, I would like to express my gratitude towards God the Almighty for letting us gather here today. Today's webinar is the first series of Science Tech as part of collaboration of Attaché of Education and Culture and Sekolah Vokasi or School of Vocational and Applied Science Universitas Gadjah Mada. So before we start, please let me inform you our agenda today. First is opening remarks from Attaché of Education and Culture in Indonesia Embassy in Canberra, Professor Yuli Rahmawati. The second one, presentation from Professor Basan Maheswari from Western Sydney University, Australia. The third is presentation from Professor Agus Mariono, School of Vocational and Applied Science, Universitas Gadjah Mada. The fourth is question and answer, and the last one is closing statement. So move to the next session. I would like to invite Professor Yuli Rahmawati, PhD, as Attaché of Education and Culture in Indonesian Embassy in Canberra to give the remark. Professor Yuli, the time is yours.
Thank you so much, Ibu Sarina. So we are waiting for another people that already registered on the registration form. Good morning and good. It's noon in Canberra. For the distinguished speaker, Prof. Basan, Prof. Agus, and also the distinguished guests, esteemed researchers, colleagues, and also the lecturers, the teachers, the students, and the other participants that joined the webinar today. And then on behalf of the Embassy of Republic Indonesia in Canberra, as the Attaché of Education and Culture, it is my great honor to welcome you in the Scientechtalk series. So it is the first one. So the planning is we would like to making the matching collaboration between Australian and also Indonesian researchers, lecturers, the universities in the both countries. So as the first team, we would like to discuss about the water and energy as the collaboration between two institutions of the UGM and also Western Sydney universities. And then we would like to open this team to another institution as well, because it's also provided the priority of the research topic for both countries. So water and energy security is the priorities for Australia and Indonesia, because it is important to addressing the challenge which requires strong partnerships to connect the research, policy, and also innovation, because we think that the university cannot do by themselves, and also the industry. So the collaboration with promote the triple helix between academy and also the industry. And I believe that through this initiative, we not only advance the knowledge, but also open the pathway for impactful collaboration and funding through the platform that we already know about, the BRIN, Koneksi, Australia Indonesia Institute, and also Prof. Basan already mentioned about to me regarding the Asia Science Mission opportunity to do the collaboration. And also others funding and also other support that we can apply for together. And I also would like to express my sincere appreciation to our distinguished speakers, Prof. Agus Mariono as the Dean of Faculties Vocational Studies at Universitas Gajah Mada, and also Prof. Basan Maheswari from Western Sydney University for their expertise and also commitment in driving research collaboration that benefits our nations and also broader region in Australia and also Indonesia. Both speakers have the title regarding the climate change, food, energy, water security, adaptation, and mitigation for Prof. Agus Mariono, and also Prof. Basan will be mentioned about the groundwater, the crisis, and also local solution through the Mars 6 approach. So I believe that the today discussion will be initiate the new ideas, strengthen our networks, and also lead to the transformative solution for water and energy challenge in the regions. And thank you very much for all participants. And then I wish you have a productive and inspiring session. Good morning. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Yuli, for giving us the remarks. So before the presentation begins, let me inform you how the presentation will be going on. First is the presentation of the material from both speakers. After that, we will open the Q&A session. So please mention your question and the person you would like to address it to. So we have the incredible list of speakers today. First is Professor Basan Maheswari. Welcome, Prof. Basan. Thank you very much for being here with us. So let me introduce our speaker first. Professor Basan Maheswari is one of the lecturers at the Western Sydney University with over 3 decades of experience in research, teaching, capacity building, and community engagement. His work spans multiple facets of water resource management, including hydrological and groundwater modeling, urban and rural water systems, river health, irrigation management, and water for livelihoods and well-being. He is also the founding director of the Australia-India Water Centre, or AIWC, and he has published over 240 works, including more than 140 papers in peer-reviewed international journals. So we are honored to have him with us today. Please give a warm welcome to Professor Basan Maheswari. To Professor Basan, the time is yours.
Thank you, Serena. I'll just share my PowerPoint. Okay. So thank you again to Professor Yuli and also my colleague, Professor August. And it's a great pleasure to present this webinar. And this is in continuation with the collaboration we are working on to develop with Indonesia. So we had a scoping workshop last year, and there are some opportunities. So title of my talk is about groundwater, the hidden crisis and local solution through the Marvi approach. So I will talk a little later about the Marvi approach. And thank you, Serena, for nice introduction. So groundwater is a very important resource. So if we look at the groundwater, aquifer stores nearly 99% of liquid fresh water on Earth. And if we look globally, as many as 2.5 billion people, every third person on the Earth, depend on groundwater to meet their basic water needs. And in many countries, groundwater accounts for over 60% of all irrigation water use, say, for example, India. And globally, this figure is about 43%. So it's a very important resource. And if we talk about Indonesia, up to 50% of water supply in urban and developed area is groundwater dependence. And Jakarta is one example, and also it's creating some issues of land subsidence. So why groundwater is important? It's essential for agriculture, drinking water, and rural livelihood because many activities depend on availability of water, and if groundwater is not there or limited, then it can impact on those things. And however, the over extraction and pollution now poses serious sustainability threats. So all the SDG we talk about, many of them are related to water and groundwater. And so these are complex, multi-dimensional challenges that requires integrated, people-centered solution because we are talking about groundwater, but also we're talking about people, livelihood, drinking water supplies, health, and all those things. So it's not a simple technical fix, but we have to think more people and their environment. And the on the top of this is the climate change. So rainfall is changing, and that also changes the recharge of groundwater. And so sometimes it will be more runoff, and and there could be less infiltration. Uh, then we have higher temperature, so that increase evaporation, and then it also reduces aquifer recharge and increases crop water requirement. Whatever we are growing, it requires more water because of the temperature and evapotranspiration increases. And we are going to have more extremes with the climate change. So more floods and more droughts, number of droughts. So that could affect how the pollution of groundwater, because when there's flooding, there are more contaminants in water, and that could affect the quality.
Oke, host aja. Jadi hostnya budgetnya berapa?
And groundwater can act as a buffer. So when there's more rainfall, we can store groundwater underground in the aquifers. And when it is drought, we can take that water out. So it can be a climate change adaptation measure. So the groundwater problem uh, in many places used to be 5 to 10 meter deep groundwater, but now have gone very deep. So you take examples of India, China, US, especially in California, there is a big issue, and that affects everything we do. And the whole issue of groundwater is it's a largely invisible resource. So there's a limited awareness of what is happening, how much water is there, and so on. And overuse is often driven by short-term needs and lack of understanding. And there's lack of there is also greed. So if groundwater is there, I want to use as much as possible. And this makes it a people-related problem, not just a technical one. And therefore, building local capacity is essential to finding sustainable solution. So it is going to be very important to include people in this system. And so approach to managing groundwater. Uh, so first thing is to understand the problem. Groundwater challenges are complex and, as I mentioned, invisible. And the solutions require, if you want to make them sustainable, it requires collaboration across sectors, disciplines, and communities. And technical approach will not be enough. We need to make people part of the solution, not they sit and watch what we do, but they should be part of the solution. And there are different approaches to solving the problem, and especially groundwater. So I have listed 5 different approaches. One is disciplinary. The other one is called cross-disciplinary. And the third one is called multidisciplinary. And then fourth one is interdisciplinary, and last one is the transdisciplinary. And so some problems we can be expert in something and can solve, but when things are very complex and people are involved, uh, one discipline can't solve the problem. And also, just having multidisciplinary is not enough. And what we have realized through the Marvi work is that transdisciplinary approach is much better, and you can find a solution that will last long time. So just want to go through. Uh, so disciplinaries work within one field. So I'm hydrologist or agricultural scientist. So I just focus on my discipline, not talk to anybody, and just try to find the solution. So single discipline expert, deep dive into one particular discipline, and that's how is done. Cross-disciplinary is the we borrow ideas from other discipline and one field with the external concept. So we try to bring some aspects. So if I'm an agronomist, I might use some aspects of hydrology into my work and some idea exchanged. So that's a cross-disciplinary. And multidisciplinaries, you have in the project team different experts from different disciplines, and they bring multiple perspective, but there is a limited sort of exchange and sort of working together. So they focus, if you prepare a report in a multidisciplinary team, so each chapter is one discipline person writing something about the problem and the improvement or solution you want to do. Interdiscipline is a better, so you integrate different fields of the problem into project, and there is a collaboration happening, and there is a blended understanding of the whole thing. Whereas transdisciplinary, you co-create across the boundaries. So really, we work together. All the experts work together to create what is possible, what is the problem, and so on. And then it involves the stakeholders. So in case of groundwater, you involve community, you involve the government departments, and that leads to our focus is on real world solutions. So actually, we are working on the ground with the people. So to explain this, all this, a little bit complicated, but I have developed this analogy. So disciplinary approach is a single fruit. Okay, you take one field, so it's an apple. So you're eating apple, so you know the taste of the apple, and you know benefits of the apple and so on. Cross-disciplinary is the fruit flavored drink, for example. So you can mix strawberry with the milk and blend, and so there's a flavor of another fruit in the drink. So that's a cross-disciplinary, but still you're focused on the fruit you have. Multidisciplinary is like a fruit bowl. So you have different fruits in a mixed together. And when you pick up one piece of fruit, you have a one particular taste of that fruit. So that's a multidisciplinary. And interdisciplinary is making a smoothie. So you mix everything together and really put in a blender. And what you drink, what you taste is a very unique taste, different taste, not the particular taste of the fruit. Whereas transdisciplinary is like a cake. So you mix all the ingredients, bake together, and you really find a different, altogether different taste. So there's a flour there, there's a sugar, there's a butter, and all those things. But what you taste is a really new taste and different things. So this is how I can explain that transdisciplinary approach is like baking a cake, and ingredients are transformed through the collaboration, and stakeholders are part of the team, not just consulted. That's what generally happens, but they are part of this uh, team. You work with them, and focus is on solving practical problem, not disciplinary theories. So that's where the difference is. And the result is a new integrated solution. And you cannot separate ingredients once the cake is baked. So just like integrated community-driven solution. So why groundwater? Transdisciplinary works for groundwater because it combines scientific, local, institutional, and experiential knowledge into one sort of project, and it actually uh, encourages co-learning and shared ownership. So all the people involved are they own they understand the problem, and they also share the ownership. And so if that happens, it leads to locally relevant, sustainable solution. So I will not go through this, but I want to talk to you about the project called MARVI. So MARVI stands for Managing Aquifer Recharge and Sustaining Groundwater Use through Village Level Intervention. So some of the highlights emerged from the MARVI work. So what we learned from MARVI, which has been running for last 13 years, is groundwater scarcity is a people-related problem, which is due to greed, lack of understanding, and invisible resource. That's what we learned. To succeed, any groundwater solution need to start with people, and we need to engage and empower through training and capacity building. And we need to develop robust village level groundwater science that ordinary people can understand or policymakers can understand, because the groundwater science is, as we know, is a little bit complicated with equations and everything, but we need to develop something people can understand and still workable, and need to engage people at all levels. So whether farmers, community, school, government, agencies, politicians, we need to bring all of them together. And the level of formal education is not a barrier to learn about groundwater science. So if you are a farmer and you can learn about groundwater science, that's the science we want to develop. And that's what we did in Marvi. So there were three important activities in Marvi: participatory data collection, sharing information, building understanding, and engaging with policymakers, government agencies, groundwater users, and other stakeholders. And fourth point I would like to add here is to really act on the learning and develop a solution that will improve groundwater security and sustainability. And eventually, the aim is to improve the livelihood and the access to groundwater. And this project has 9 organizations involved, led by Western Sydney University, 30 researchers, and 35 farmer researchers. And the project has been running since 2011. And the project was carried out in India, in the state of Rajasthan and Gujarat, western states. And these two watersheds called Megraj watershed in Gujarat and Darta watershed in Rajasthan. Both watershed had area of about 5,000 hectare, and rainfall in the area is about 600 to 700 millimeters annually. So the Marvi approach, what really that was about. So if we talk about groundwater, there are three key elements. One is the science. So how groundwater infiltrates, recharges, moves around the landscape or in the aquifer and so on. So that's the science. And then the community, the people who use and who depend and who will be affected if groundwater is not there or limited. And then there's a government. So they have a policy, regulation, governance, and also funding. And what Marvi did, we brought them together. So earlier there was some interaction, but not really in a way that it can lead to sustainability. And there are four sort of actors in Marvi. So one is called BJs, which is called Bujal Jankar. That's a Hindi word. Bhujal means groundwater. Jankar means informed or experienced. And so these are the local farmers and community people. And then the other stakeholder are researchers. So some like us. So we can measure things, we can analyze and like that. And then there are schools and village communities. So they are the part of community who depend on groundwater. And the local government, state government, central government. So we try to connect with all of them and sort of bring them together to a point where we understand each other's point of view. And so these Bhujal Jankars, or in short, BJs. So these are the local volunteers. And so 25, so that's what we started with, 25 in Rajasthan and 10 in Gujarat. And we gave them training in basic hydrogeologic aspects, mapping, water table, water quality measurements. And then we had, once they got trained, they became local champions in the villages, and they interface with the research team and the community. So they really were the local scientists. Uh, and they are the farmers who left school long time ago. They're doing farming or some other things. And so they are the local groundwater experts in their own setting. And they empowered and felt valued because they were working with us like fellow scientists. So we didn't distinguish them. We sort of treated them as a colleagues, not like we know everything and you don't know it. So we are telling you, not like that. So we learned from them as well. So what we really did in Marvi, so train these BJs and work with them on ongoing basis. So not just one time doing and then come back 3 months later, but it's sometimes daily, weekly, fortnightly conversation, working with them, facilitating, nurturing what they need to do. And these beaches collected groundwater depth data, rainfall amount, and water quality, checked in water level. They also help in socio-economic data collection. So they were just like citizen scientists working in their own villages. And we also worked with local schools and community groups and worked with the local government and state government. And we developed tools and resources for data collection, analysis, capacity building, so learning materials for the BJs. And we have developed an app like MyWell, which is available now, and connected with policymakers and state and central government levels. So this is, in summary, what we did. And this is one of the BJs. So the instrument he is using is a measuring tape and a float. So that's how you measure the groundwater level. We also used sensors and all those things, but just to back up the data in case we don't get good data. So, but eventually these BJs collected very reliable data, and we even published in international peer-reviewed journal based on those data. And so we also install, as I mentioned, the groundwater level sensors and automatic weather station, and we uh, help them to how to understand and measure rainfall amounts and so on. And this is one of the weather stations. And the person you see is Pralat. He's the local groundwater Marvi facilitator. So we install a number of them in these villages. And these BJs went for training in different things. So, for example, preparing maps, land use maps, surface geology maps, water resource maps, and and so on. And they also worked on the local water balance. So again, all these things were done in a very simple, understandable way in their own local language and at their level. And so what that means is that even complicated science you can simplify and make it useful for the people who are going to work as a local citizen scientist. And so these are the pictures of farmers being trained, for example, in the field. They are being sort of trained in how to measure groundwater levels, some doing meetings, classroom teaching. This is one of the BJs marking the well where they are going to monitor and so on. And the BJs also monitor the check dam water levels. So if we know the rainfall, groundwater levels in the wells, and check dam water level, then you can develop the groundwater balance, water balance of the area. So you know how much water is available as a groundwater and how much they should use. So by having these measurements, it's possible to do that. And we had lots of meetings with the community to really explain, and they be part of the solution and part of the thinking process. And we didn't work like an expert with them. We were more like a facilitator. So, and we listened to them, we worked with them, and then they found their what will work for them to improve groundwater situation. So this is a group of BJs. Working with women was very important, and there were some BJs also, women BJs. And this is about my well app. So it is going through a revision, and there will be a version for Bahasa Indonesia as well. So can be used anywhere to collect groundwater level data, rainfall, check dam water level, water quality, and you can see where the measurement points are and so on the map, and you can see the details. And this is one of the graphs from the MyWell app. So if you have the data, you can see how things are changing, and then you can have an understanding about the groundwater management. And this is one of the BJs. So many of the BJs use this MyWell app. And what's next happening? So from monitoring to management. So once we understand what is happening to groundwater, once we understand what is happening to groundwater, the next logical step is practical action to achieve groundwater sustainability. So engagement and monitoring is the starting point, but then we use those things to understand what's next or what can we do. So we need to, and what that led to is the collective action, because one person acting will not work, especially in groundwater, because groundwater is a common pool resource and it's underground. So you can't really control, okay, you have this much and the other person have this much. But if we work, if we understand how much is available and we manage this as a common community pool resource, then there is a solution. So from the work of the Marvi, we came up with the 4S strategy for groundwater sustainability. So these 4S, first S stands for surveillance. So surveillance means monitoring, community-based monitoring of groundwater levels, quality, and other parameters. And then store, which is recharge. So we need to recharge groundwater. So if we take all the time and not recharge, then groundwater level will go down, and then we will have less left behind. So we need to recharge aquifers through check dams, percolation tanks, or some way of managed aquifer recharge. And then we need to share groundwater. So that's the third S. That means to promote equitable sharing of groundwater within and across communities. And also, fourth S is about sustain. So once you have recharged groundwater, stored groundwater, you share it in some way, but it has to be sustainable. So long-term protection and responsible use of the resource. So this strategy is best implemented through what we have done in India is village groundwater cooperative. So really form a cooperative of the groundwater users and then enabling local stewardship and co-management. So actually people work in a group or as a cooperative, uh, then they do all these things to manage together. So I think I'll skip this one. So this is to explain in a pictorial way. So we are monitoring groundwater level. That's the first stage. And then we recharge groundwater. And the third one is sharing. So we work together through village groundwater cooperative. And fourth is sustain. And sustain for livelihood and resilience. So all these things. So the forest strategy captures the spirit of Marvi, enabling villagers to understand, act, and manage their groundwater resource together. Not one person doing, because one person doing good thing won't help groundwater sustainability, but because it's underground, so if one person does good but other don't do the good, then it won't work. But if everybody working together and looking after the resource, then it will work. So this is how village groundwater cooperative can work. So people are working together and they understand and so on. And this is one village groundwater cooperative we operationalized last year. And this is the launch of the groundwater cooperative in Rajasthan. So the idea is you at a village level, you form this cooperative, and then at the block level, you again multiply and district level, state level, and central level. So that way you can manage the groundwater more sustainably at the national level. So you have to start at a local level and then you outscale. And these are some of the farmers of the cooperative. So their motto is our groundwater, our cooperation, and our development. So one of its kind in the country, a farmer-led initiative for groundwater sustainability at the local level. And so there are 30 farmers and 22 hectares of land. And they have recharge structures, pipe network, groundwater sharing. So, and this is the map of the village cooperative. And so they are sharing groundwater. And this is after groundwater. So before cooperative, their crop yield was about 15,000 kilogram of wheat. And after that, now it's 70,000 kilograms. So just by having the cooperative, sharing groundwater, recharging groundwater, they could irrigate the whole entire area. Earlier, they were not able to do that. So it's more than three times just in 1 year change. So what this means, all this means is people first technology, simple, scalable, effective. This is what we need to do. And now these new technologies coming, new AI, game tools that can help deepen. So we need to develop something on those lines because smartphones are now everywhere and technology is changing. And groundwater being invisible, now we can make it visible through visualization and using AI or many other things. And Marvi is expanding. So from India is going to other countries, and Indonesia is potential. Potentially, we can do that, and it's a citizen science. Uh, so, to summarize, for managing groundwater and sustaining it, we need 4 aspects: groundwater levels, rainfall, water quality, check dam water level. And if you have above information, we can understand what is happening to groundwater and what can we do with it. Uh, and it is important that we are solving problem that was created by people, and any good solution need to include their capacity building to understand and tackle their water problem. And use of technology should be such that it works with people, not removed from them. So I think this is my final takeaway. So groundwater challenges need to be integrated, people-centered solution, and it should be transdisciplinary approach, and that's okay. Thank you.
Thank you. Thank you, Professor Basan, for the insightful presentation. So after this, we will have also one another speaker before we go to the Q&A session. So ladies and gentlemen, please welcome our second speaker, Professor Dr. Engineer Agus Mariono, IPM, ASEAN Engineer, a leading expert in water resource management. He is currently the Dean of the Vocational School at Universitas Gadjah Mada and has an extensive academic background with a doctorate from the University of Karlsruhe, Germany. Professor Agus Mariono is known for initiating the Indonesian river restoration movement and promoting rainwater harvesting across the country. He has received numerous awards, both national and international, and holds several patents in environmental engineering. In this morning, he will deliver the presentation about climate change, food, energy, and water scarcity adaptation and mitigation. We are honored to have him with us today. Please give a warm welcome to Professor Agus Mariono. To Professor Agus Mariono, the time is yours.
So first of all, Alhamdulillah, I do thanks to Professor Yuli Rahmawati, the Attaché of Indonesian Embassy in Australia, and also my best friend, my colleague, Professor Basan Maheswari, who always ready to collaborate with Indonesia and has several activity with our expert and our people in Indonesia. I think this week we will have also a kind of workshop with Brin together. I will attend in 29. I think I will attend for 1 days to attend the workshop. Thank you very much also for the whole participant who already coming here in this morning. I hope that we have a kind of idea how to develop, how to accelerate the development in water resources in order to mitigate and adapt the climate change that we have already have today. So allow me to share my presentation. Yeah, first. Do I have already my presentation?
Yes, Prof. Agus, it's
Yeah.
already clear.
Yeah, a moment. I will see. Okay. So, it's okay? Yeah. So, thank you for the collaboration between Attaché of Indonesian Culture and Education Office and School of Vocational School of Applied Science, or you can say School of Vocational Applied Science, Gadjah Mada University in Indonesia. So climate change, food, I mean, energy and water scarcity adaptation and mitigation. I have two cases. First is technology and community movement of rainwater harvesting in Indonesia. And second case is about energy. I think two very important thing, water and energy. Okay, for the whole Indonesian archipelago, we have a very big country. We have a lot of people. We have to work very hard to find out the best way to accelerate our development now and in the future. So the problem is too much and too little water. We know all of us. Sometimes we have drought, and sometimes we had flood. And also we also have a problem like this. We have this problem. We face people who has a water scarcity, but suddenly we have a very too much water. And for example, yeah, we see also this problem in Gunung Kidul that people queuing for water, yeah, and trying to have water to pump water from 200-meter deep water. Of course, the energy for pumping is very high too. And yeah, and we now have actually rainwater with very high quality, and not only good, but very high quality. The best quality the world in Indonesia is rainwater today. Rainwater is a very good quality compared to, for example, river water, of course. Compared to spring water in the city, rainwater is better than that. Compare also to maybe gallon water is also rainwater is better than gallon water. So, and the volume is amazing. It's very high volume that we have because in Indonesia, the archipelago area here, the rainwater is very, very huge from 2000 until 4000 millimeter per second. So we have enough water and good quality water for drinking water. But the problem is that until now, I think only, less than 2% of Indonesian people using rainwater for their daily life. So the solution is rainwater harvesting movement, a movement to support the people to understand about water and rainwater, and then to support the people to use rainwater, and to support the people also to know about the quality of the rainwater. I think the quality and rainwater, something like that, yeah. For example, this is in Bahasa Indonesia, air raksa, for example, zero. There are no air raksa. Ferro is only 0.02. Detergent is no detergent. So all of this thing is good. Even pH, 7.4 is the best pH in the world, I think. So this quality is of rainwater is very good. That way we have to support people to use rainwater. Okay, and for that kind of purpose, it's not just going to the people and discussion about the rainwater. We have to make a kind of concept how that this movement is move very fast and moves not only without understanding, but with knowledge. Like Professor Passan say, we deliver not only tools, but we deliver also knowledge to the people so that the people also has knowledge and develop their knowledge by themselves, depend on their life, the situation, the condition. Yeah. So first, we try to understand the climate change. So as an expert, I have to realize what is climate change going on today. And then we have to make research of rainwater. I have already that things. And then we have to make a technology to bring that kind of thing. So without technology, you cannot bring anything. You cannot only say to the people that it's good, but you have to make a kind of a technology, even a very, very appropriate technology, very simple technology, but you have to bring that to the people so that people can try to do that. Then you have to develop a technical and vocational training for the people. Yeah, the people should be trained. It's not let people buy this technology outside, but they have to do by themselves. They can create. So then they develop. And then you may also make a teaching factory in the campus or in the school, small teaching factory in order to develop people, student to do or to make a tools technology for the people surround the school or something like that. And last of this, we have to see what's the impact of our development, of our activities. If the impact is good, then okay, we have continue because the impact is there, the positive impact then. Okay, this is a comprehensive solution, development of science, technology, and vocational training process to harvest rainwater for clean water source. Yeah. So this is a climate change. So no doubt that the climate change occur in Indonesia. Yeah, the temperature here, you see the temperatures rise in this small graphic, rise very, very rapidly here. 0.75 degree for 48 years or 1.5 degrees Celsius for 100 years. This is already in the limit ring that we cannot jump to the limit, yeah. And then, here the rainfall, the annual rainfall is also slightly increased. Mr. Basan said it will be a lot of high rainfall. I met also that the rainfall, the maximum rainfall or the not extreme rainfall, but the high rainfall is occur much more than before. Yeah. So in the future, we will have high rainfalls numbers more than now. So this is also the climate change. So we have to do something to avoid, to adapt and to mitigate the problem. That research in water on quantity. Yeah, you see this quantity of water from Aceh, rainwater from Aceh to Papua. It's nice. 2,000 until even 5,000 in Sumatra Barat. Yeah. In West Sumatra, we have 5,000, and sometime in Maluku, we have also more than 5,000 millimeter per year. This is a huge amount of water that we can use there, and the quality is very good in that base. Okay, what about quality? Yeah, I have already have a lot of research about quality, and I justify that the quality of rainwater is very, very good, even better than all the rainwater. If we compare to groundwater, like well water, the rainwater is better. If we compare to another water, maybe also with river water, rainwater is better. So no doubt that we can use rainwater as a source for water, for drinking water and so on. Yeah, and then we try to make kind of technology. This is very simple technology. We call gamma rain filter. Why simple? Because we would like to bring this technology to the people, that the people can learn about that and can develop by themselves. Of course, this technology is already patented. Yeah, patented, but the patent here is social and commercial patent. If people want to buy, you allowed to buy that. If we want to have permission to use for social purpose, you are allowed to do that also. And this patent is the best patent in 2020 from Gajah Mada University. Got the best patent. Yeah, this is the technology. So technology is very important. It's simple but important for the people. This technology of rainwater harvesting that you can also have. Yeah. So this is a technology. This is the what we call filter, a leaf filter. Yeah, leaf cannot go down. Yeah, so all of leaf is go out and the only water. And this is the construction of a sediment. Yeah, avoided sediment or those sediment filter of first flush. Then going here the water, and then here is we have the fine sediment filter. Okay, so this is complete. then we have a very good quality of water.
Ya, rupanya
If the
bagus.
water is too much, then the water can flow out, going to the groundwater or going to the well water. Then we have water outside, and we have also water enough in groundwater. That way, I very lucky to have friend Professor Basan, because I want to join with him in order to harvest water for groundwater. Yeah. Okay. Now then we have already roadmap 2011 until 2025. Yeah, here we try to install 1, 2, 3, 4, 5, 6, 7, 8, and then now we have a laboratory. Yeah, laboratory for a special for rainwater harvesting laboratory in School of Life Science Gajah Mada University. So this is a roadmap we would like to have. This is the place that we have already set up the community. Yeah. And this is the student who work very hard to bring this knowledge to the people. And here the community in Molucca bringing rainwater harvesting to the small island. Yeah. And then, so this is the movement that we already done. So the training is made. Yeah, this is training in the laboratory. The people, the student make that kind of technology by themselves. So every student already understand how to make and so on. Yeah. And here we work also with industry. In that case, it's Ruchika. So we have also support from Ruchika to do that. Yeah. And then, so we already have a lot of places that we already set up this kind of rainwater harvesting. So, you know, this is a kind of leverage factor, that the factor that we bring to the people, and the people understand how fine, how nice is rainwater, and then they can develop it themselves in the future. So this is the training and also the community that already growth in Indonesia. Yeah, I think more than 30 group that already work with rainwater harvesting, like for example here, yeah, and here also in another island here, there. And from that kind of technology, then we, and also movement, we develop 9 intellectual property and patent. For example, gamma bamboo rain filter is a patent. Yeah, and gamma rain filter is patent too. First plus is patent, injector is patent, 4 patent, and gamma rain filter UV system is also patent. And here is also patent and so on. So from one technology and one mission, then we can develop a lot of patent, yeah, in Indonesia. We try to have a patent of Kamarin alkali, yeah, and have also packaging and Kamarin disinfectant too. So this is what we call, we develop a technology and we also develop people and so on together. So this is our innovation. This is bamboo rain filter. Here, bamboos from bamboos, because some place they don't have pipe, yeah, pipe housing. They have only bamboos. So we create the bamboos as a pipe. We create also have developed rainwater drinking water here. So tap water, and we have also several things here. We have rainwater injector to the wheel. If you have a wheel, sumur, yeah, then you can inject freely water, rainwater to the wheel, so that in the dry season, you have no problem with water. You can use the water in dry season. Okay. This is the education for the people who do that. Even the army, Indonesian army, working together to do that. Yeah, this is really a movement that people really want to do together, because they can do that. Yeah, they have no doubt to do that because they understand about that. So, and then we develop also AI, yeah, AI to understand the reaction of water, of groundwater if we are inject, yeah, the water level and also the quality of water. You know that the quality of water due to injection is increased step by step. If you inject rainwater, and then rainwater is very high quality. It has very high quality. So the quality of groundwater or the quality of your well is better. It's better and better, step by step. This is what we want to continue to the next. That every people who has a well, yeah, they may also inject rainwater after filtration to their well water. Okay. And then we develop several things here. For example, we create a book for that things. Yeah. So knowledge is very important. So we create a book, we write a book about rainwater harvesting. We write a book about uh, systemic thinking and so on. And we try to have a TikTok. We have tried to have X and so on. We write in the newspaper. So that kind of thing is to support the people. It's not only one place in Jogja, but in all of place in Indonesia and also even in the old world, in other countries like in, for example, Australia or New Zealand or people in Africa, people in so on. They can also type in YouTube, then they see what is going on, what's the program of rainwater harvesting. Yeah. So this is the group, yeah. GMHI is Gerakan Memanen Hujan Indonesia, Indonesian Rainwater Harvesting Movement. We have a lot of group here, yeah, 19, 20, and number 20. The group is located in several places. So then we deliver every day, deliver every day knowledge about rainwater so that the people learn about that, yeah, from Java, Yogyakarta, Java, and from to the whole island in Indonesia. And we hope not too long that our rainwater movement will be achieved in very East Indonesian part and very West Indonesian part there. Of course, to Australia and also another country. Okay, so I think I'm very agree with Professor Basan that we have a kind of systemic approach like that. I'm sorry, he is a rainwater harvesting movement supported by local government, university, forest and environmental minister, BBBD, private sector, NGOs, news, private disaster institution, and so on. So we collect all people to work together to support that. And then also based on social, economic, and ecology. So social, that means due to rainwater, that the people will meet each other, working together. The economic, using rainwater, they can reduce the spending for water, for drinking water. Ecology, of course, due to rainwater harvesting, and also releasing the water in the wheel, so the ecology will be good. Also, the food will be also increase. Yeah.
Soal gejolak masih ada, tapi ini pelaksanaan undang-undang gitu.
Sorry.
Kalau ada yang komplain, share review aja ke MK ayat 4 dan ayat 5 pasal undang-undang
Tolong di stop itu Mbak host. Ya.
PPI harus selaras melaksanakan dari undang-undang ini gitu Pak.
Okay, so sorry, Prof. Please,
Host.
Mbak Alin, I'm not the host.
Ini amanat undang-undang. Maka di RPP-nya ya demikian, selaras tidak gitu. Jadi bukan lagi kita tanyakan siap
Pak
tidak
Murdiono,
siap.
could you please mute the microphone?
Itu mungkin dari kami.
Oke.
Mbak Alin.
Mbak Alin bisa di mute-kan dari hostnya. Hostnya bisa mute-kan ya. Okay.
Ya, sudah Pak.
Okay, yeah.
Sudah, Prof.
So we use also to support this movement, we use WhatsApp, Skype, like we have Webex, yeah, X, IG, TikTok, and so on. This is the social media, very cheap media to develop that kind of thing. The media is not not used for hook, but we use the media for something very important like this movement, yeah, Zoom and so on like today. And we also create a network. So every dot network here related or connected with us. So every question, yeah, if the people has any question, they can also share to the people, and the people will answer the question and so on. And we deliver knowledge every time to the people, so the people understand, and we will also deliver knowledge to us and to other network here. So the network will be very, very good. So that way, every year we have we can have one congress, yeah, rainwater harvesting congress, because the network is working. Yeah. Okay. So we use also artificial intelligence, building a network, building a sub-network, building content, and so on. Yeah. So this is technical and vocational training, dissemination, rainwater harvesting in Indonesia. This is dissemination. The dissemination is not always from me or from my friend, but the people in the community or the leader of the community can already explain about that kind of thing. Even Pak Ganjar Pranowo can explain about that. So this is a kind of network movement that not only one person, but everybody can explain and develop that kind of their own knowledge. Sometimes that is wrong, but it's small wrong is no problem. Yeah. Okay. This is also the alumni of Gajah Mada University working in several places to make millennial bootcamp training in teknologi pemanen air hujan, gamma rain filter. Yeah, so this is the leader of Kagama in Kalimantan. So we use also artificial intelligence for having appropriate design and detailed design of area, for calculating the cost of building and so on. Yeah, we can use AI for that then. Yeah. Technical and vocational training, we are ready. We use KKN, yeah, kuliah kerja nyata, student services movement. We have already more than 25 places in Batam, IKN, Gorontalo, and so on. The student coming there, yeah, and then they develop that kind of rainwater harvesting and invite people and trying to make a discussion with people. So we have a Congress too, yeah, Congress 1 in 2018, 20, 29, 20, 2020, and then the 2024, we have also the Congress. Yeah. We develop a teaching factory because we want that the students also have an ability to create that thing and to develop that thing. So we have teaching factory, yeah, training, it is very important. So vocational and applied science is very vocational because the implementation of knowledge is very important. So that the people, the student is also has a kind of proudness that they can realize what they learn in that case. Yeah. Okay, and then the positive impact has already happened. Yeah, positive impact that people suddenly has water for drinking water. Yeah, and some of people explain that the rainwater harvesting has a various impact in several regions, including the establishment of 30 rainwater-friendly village throughout Indonesia and so on. Yeah, and here is positive impact of science, technology, and vocational training rainwater harvesting in Banyumane. Yeah, people in Banyumane already use their things. Yeah, and they also happy with the drinking water. They drink together. We create a water for drinking water. Yeah, and conclusion for that case is the problem climate, also flood and food and water scarcity. Solution is rainwater harvesting, but we have to make a movement. It's not only one point, but we make several points and trying to make a network and trying to distribute knowledge and trying to motivate people to do like we do and trying to support people. If they don't, if they cannot answer the question, they can ask me and we can discuss about the answer and so on and so on. So that was the rainwater harvesting. And for the energy, yeah, I would like to continue. I'm sorry, I have to continue one more because Prof. Yuli asked me to deliver about technology in micro hydro for community development. Yeah. So potential of mini and micro hydro in Indonesia for community development, for irrigation channel, any irrigation channel in small rivers, and drinking water pipeline system. So there's 3 potential of energy for community development. Yeah. Why mini and macro hydro? Because simple. Yeah. If you have just water, a river or irrigation, then you can create that things. Yeah. Easy to develop, not expensive at all, adaptable for community, 24 hours operation, renewable, high potential in Indonesia because we have a lot of river, we have a lot of irrigation channel. Community-based people can do that, the community can do that, and the turbine and the electric panel can be produced in Indonesia. So this is why I choose microhydro for supporting the community development related to energy. So the formula is very simple. Power is head, discharge, efficiency, gravity, and unit mass. Yeah, time that one. Then you will get. Or power is 7.5 each time, head time discharge, then you get it. So mini hydro. This is very simple. If you have drop something like that, that means this is energy. Why don't we use this energy for our purpose? Why? Yeah. So if we see irrigation system like this is a bendung or weir. So then we have a lot of irrigation here, primary channel, yeah, and secondary channel. We have a lot of here, and every system here there is sometimes drop like this. Sometimes they have drop, not sometimes. It's always that drop, and the drop can be used for that. Like this one. This one is very huge drop here, like very high here. Yeah? I don't know this one. This is in Kedung Rong one in Yogyakarta. Yeah, if we calculate, yeah, so the cost is about 2 billion. Yeah, a payback period 3.15 years only. This is very good for business actually. If all of energy sell to PLN and the PLN want to buy, yeah, the problem is this time. If we have a very good quality of energy, then PLN will buy that energy, then we have very good business. And if the community can use that kind of business, it's very good. And the community get money. So microhydro, this is a kind of, ini bahasa Indonesia, ini kayak sumber energi berarti kayak apa ya, tambang ya, tambang batu bara setiap hari itu dia menghasilkan uang. Kalau energi ini, if this energy can be sell to the PLN and PLN will buy that, so the people is very happy because they got money for developing their village, what I mean, something like that. For example, this one should drop, this is drop too, yeah. This drop here can be used also for microhydro power plant. Yeah, this one, Kedung Rong 2, there is 2 places. I think here is about 3 until 5 cubic meter per second, and the head is about 6 meter head. So then we have get already about 90 kilowatt from here. This very small irrigation channel can be used to for that microhydro. This is very big, yeah. So it's not used until now. So we can use that. Yeah. So this is also, then we can use for power. How to use that? No, not yet. And then how about the river? If we have a small river, then we can use every part of places that has a very enough head difference between one place to the other place, like this one here. We can use that for microhydro. So like here, up there is a river, and the people suck the water here and pump, and this is the turbine house. So the people can have very high potential of energy because here about 11 degree 11 meter here, yeah. So depend on the discharge. So this kind of thing is possible. This is in the river also possible that we still has a lot of water here, then we can calculate how much energy that we can gain from that thing. Or here, still have, this is for irrigation. And if we go to along the channel here, sometimes we have also drop, then we can use that. Or here, we can use the water still. Yeah. Or here, we can use the water for hydropower plant. Like we can make this channel wider, and until here, for example, then we can suck the water to the turbine, and we can suddenly has energy. So I say again, it's simple. Yeah, this is the schematic. You have a river or channel, and you have stabilization pond. Then you have a turbine. You have generator here. You have also control, electrical control, and then you have ballast load here and service. It's very simple. The problem is how to use the energy. This is the problem. Because microhydro is 24 hours running. It's running for 24 hours. If you use only in the in the night, for example, 12 hours is gone. So you have to find out the industry, small industry, who need 24 hours electric. Like, for example, industry for ice making. Yeah, the ice making is 24 hours. Yeah. So you can do that. So this is the development. I give you a example, very easy. Yeah, this is powerhouse. This is irrigation channel, inlet, intake. This intake here. Yeah, this is stretch rack. Yeah, yeah. Then this is the intake coming here, and this is the powerhouse, and you get energy. Yeah. Okay, migrate to drop structure, and the drop is about only 2 meters. Yeah, we got here about 5 kilowatt. Yeah, from that thing. This one here. Yeah. So even very small river, my student made a kind of micro hydro small, and they produce light here. Yeah. Okay. The turbine use is turbine for low head because simple assembling, simple in operation, simple in maintenance. Indonesian products. Yeah. Okay. This one. This is a turbine. You are from mechanical engineering. Know well about that. This is very simple. This generator is turbine. This is a turbine. Is a generator coupling. Then you can have like energy from that generator. Ready. So this is Mr. Eddie, yeah, the Cianjuang Inti Teknik Production. This turbine is produced in Indonesia, and they have also immersion turbine propeller, yeah, for very small capacity of turbine. So the other thing is the potential of many microhydro in the drinking water. Drinking water pipeline system. If you have every city normally has a drinking water pipeline system, and you know that the building here we call in bahasa Indonesia is bak pelepas tekan or pressure release chamber. The pressure release chamber is actually has a potential for energy. We can use that for energy, yeah, using microhydro. We use of course small scale Pelton turbine, yeah, very small scale Pelton turbine, because the head is can be until 100 meter difference here, yeah. The community around that building can use that. And you know, this is the pipeline system, for example, here in Ngobaran in Jogja. Yeah. So here we pump here, and then after pump, we release the water flows down. Yeah. Yeah. This is, yeah. And that place, we have energy actually, because from 380 until 240, then that means we have 338 head different. From here to here, we have more than 60 head different. So every head different is actually energy potential of water. So what I mean, he still have a kind of energy that we just release, just let it out. So we can use here for energy power, and the people can use the energy for everything, yeah, in that area. Okay, I will click again. So this is good. Or this one, yeah, this one, we pump up again, pump up, we need energy and pump up. We pump up here, but then we pump down, we sucks down here, yeah, for example here. Yeah, you know here. So that means we have energy here actually. So we have another system here. We pump up and let down and release down. Yeah, release down again. You know here from that R4 to PP3, we have 380 to 354. Then we have 25 head different here. So again, that payback period only 3.9 or 4 years only. Payback period, I calculate roughly, business plan, only 4 years. 4 years is a good business if people want to do that. Yeah. So then, like rainwater harvesting, we would like to have a movement in microhydro movement. You local community, we have to support local community. And the utilization is for something like that, for example, for crushing the rice, yeah, and for lighting in remote area, and for small and medium enterprise, lighting again, for hatching duck eggs, for example, and so on. So that was what I want to say to you, a little bit long. I need time. I'm so sorry, but that kind of movement, so rainwater harvesting movement and microhydro energy power development movement peace community, I think is very good for our development for the whole country. Thank you very much. I will stop share. Thank you. I give it back to the moderator. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Agus Mayono, for the very insightful session that you share with us. So now is the question and answer session. I would like to give the opportunity for all the participants to give the question. Yeah. If you are able to open your microphone, you can ask directly. But if you cannot, maybe you can drop the question in the chat box. Okay, so first here we have the first question. Which kind of question for Professor Basan? So the question is from Tegar Cahya Widodo. The question is, what specific challenges or opportunities made India as the ideal location for implementing this kind of groundwater management initiative? So that's the question for Professor Basan. Could you please share with us, Professor?
Yeah, thank you so much, and very good question. India is the largest user of groundwater, and with the Green Revolution, the groundwater use really accelerated, and also the use of the pumps and drilling technology. So groundwater gone very deep, and there are many initiatives happening in the last 15, 20 years, but the groundwater was still going down. So some of my colleagues, we realized that we need to develop something which involves community. They are the part of the solution. And so we, instead of doing modeling and all other things, we resorted to working with people, training them, and then developing the science they can use. So that really provided very exciting opportunity. And so to answer that question, uh, India was really good experimental ground for what we wanted to do. There was a strong need in 10 years ago or even before. And we got a good support. And now what we started in 11 villages, it has gone to more than 10,000 villages in 7 states of India through the national groundwater program called Atal Bhujal Yojana. So, and there were lots of challenges. It was not straightforward to really bring community to be a citizen scientist. So measuring things accurately, it took long time. Even we had to explain how many centimeters are in meter when they are measuring. And then once they understood the importance of their data, the accuracy they need to measure, and then reliability, they become really part of the whole idea. And this, what convinced me in last few years of, in last 13 years of work, is this village groundwater cooperative. When the farmers get together and they follow this 4S strategy, means monitor, surveillance, monitor, recharge, share groundwater among themselves, and then do things which will sustain. And we have seen already the cooperative thing, and now the government is trying to pilot, and I think it provides a great opportunity for Indonesia to monitor quality of groundwater, recharge groundwater, and then manage as a community resource. And I think it very well fits in with the Professor August's idea of community level rainwater management. So I think the two concepts really blend together very well.
Thank you, Professor, and also thank you for Tegar for giving us such a critical questions. And then move to the next question. I will give the opportunity for those who already raised their hand. For Miss Sylvie Nur Oktalina, could you please open your microphone? Thank you.
Thank you so much, Mbak Sarina Hanifah, for the opportunity, and also for Professor Agus, who let us know this information so we can join with this very useful science talk, I think. Allow me to introduce myself. My name is Sylvie Nur Oktalina. I'm from Forest Management Study program from Vocational College under Professor Agus. And my first question is Prof. Bazan. You mentioned that the groundwater is a common property. So, however, to manage this, we need the collective actions. I just wonder how to manage this kind of collective action. And based off on your experience, you mentioned about the cooperative in India. So I wonder how effective this kind of cooperation, cooperative to do the collective action. And do you think that it might suitable for Indonesian context?
Yes, sure.
Yeah, okay. And my second question is for my dean, Professor Agus. You have so many technology that already published regarding rainfall harvesting, and now you also discussion about the micro hydro. All of that kind of technology, in my understanding, is to how to utilize the water and also how to conserve the water itself. And I think it might be more usable if we also consider vegetation or trees as the whole of the system. So it might be more complex and more holistic to manage water in utilize the water and also for conserve the water itself. What do you think about that? Thank you.
Thank you, Dr. Sylvie. So you ask a very relevant question. Now, how do we formulate these cooperatives? And it took quite some time, at least 3 years, to convince the farmers. First, they had to learn that groundwater is a common pool resource, and that came through monitoring. And they realized, say, when we started the project, people thought um, groundwater they have coming from 200-kilometer dam somewhere, and there is a river flowing underneath, and there is plenty of water. And but when they start monitoring and rainfall and groundwater levels, they realize that what is recharged is what is available, and that really changed their thinking. And then we really worked with them, lots of workshops, and they realized that if I drill deeper, my neighbor's water will disappear in the well. And so they realized that it's a common pool resource, and we have to work together. Going deeper is not a solution uh, because it's not creating any extra water. What is there in the aquifer and recharge is the water. So they eventually formed this cooperative, and now they're sharing. So farmers who didn't have well, uh, the other farmers are giving water to them without any cost. And so it is what we have done so far. It is working, and it has a potential to work, and there's a lot more to learn from it. And coming back to Indonesia, how it can be applied. So Indonesia has a lot of good community level work, and people are very uh, sort of cooperative type. So they want to work together. And I think if we can introduce this idea in the urban areas, in rural areas, to monitor groundwater levels, monitor rainfall, then I think there is a movement, there could be a movement to really manage it better, surface water, groundwater together. So groundwater is more for, in Indonesia's case, for drinking water and some industrial needs. Agriculture is less. But I think if we manage, because water cycle is groundwater, surface water, and the water flowing in the rivers and so on. So it has to be, it's a one component, one total water. So it have to be managed together. And so I think Indonesia has a great opportunities if we can introduce a concept like Marvi, where community monitors, recharges, and share groundwater and sustain groundwater quality and the amount. Um, and it can be as adaptation, one of the adaptation solutions for climate change.
Thank you,
I hope I
Professor
answered your question.
Hassan. Thank you. And how about the second question? It's addressed to Professor Agus Mariono about the trees as the whole ecosystem. Did you please share with us?
Yeah, thank you very much, Mrs. Sylvie. Thank you very much for your very nice question. Yeah, let me share you the video. This one.
Buahnya lebat ini.
Can you hear that one?
Ini karena airnya kecukupan.
Hello.
Yes, we can hear the sound. It's in
Okay.
Bahasa, right?
It's in Bahasa. Yeah.
Yeah.
Ya, buahnya lebat ini. Tuh. Ini karena airnya kecukupan.
So this is the impact of sorry again. What can you hear that? Sorry again. Sorry. I will share one video that the people really. Yeah, this is the avocat.
Tapi mungkin belum ada 3 tahun ini pohonnya ini. Ini buahnya lebat, bisa dicium itu Mas. Avokatnya itu. Nih. Ini hampir 1 batang aja ini sampai di apa? Di sangga ini. Nih, kasih tiang karena kelihatan.
Okay, I will show you, Mr. Sylvie. Mrs. Sylvie, you are right that the rainwater harvesting movement, the big amount of water is also released to the well water or sumber resapan, well infiltration water. Yeah, and then the water well flows in the groundwater. It's not only in the groundwater but also in the upper of the groundwater, the earth. Then the vegetation, the trees will be enough water, have enough water, and the production of the agriculture will also rise up very, very good. Like this video is from Rawapening. Rawapening is in Middle Java and near Semarang. That the people has already 100 rainwater harvester install 100 rainwater harvester plus infiltration well. And after 1 year, they have no problem with water because for drinking water they have, and in the groundwater they have also water, and also there are trees like here avocado, and also mangoes, bananas, and so on, growth very, very good, very fast, yeah, very good. So that's kind of positive impact that we has already found, and we will continue because the positive impact is already there. So that is my answer, Mrs. Sylvie. You are right that we have to think also about the environment, the trees, and so on. Thank you.
Thank you, Professor Agus, for the answer. Ms. Sylvie, do you still have any unanswered? Okay, thank you, Ms. Sylvie. And then next, we would like to let Mr. Ahmad Agus Setiawan for giving us opportunity to give the question for our excellent speakers. Please, Mr. Ahmad, to open your microphone.
Thank you very much, Ibu Sarina. Thanks, Professor Agus, Professor Basan, for the excellent presentation. It's very clear. It seems very cold there in Canberra, Bu Yuli. Yeah. So my questions concerning about the population, Professor Basan and Professor Agus. That population in India and Indonesia also we know that booming number of populations, and the worst scenario is that many people coming to the basin area, the water basin area. They built such building without any permissions and so on and so forth. And currently we have a very excellent story from one of our governor from Jawa Barat, where he tried to clean up all the situations, all this the building that not having any kind of permit and so on and so forth. But the thing is clear, it is very important. Water, we need it, but the problem is that when we stop it to flow and others, the problem will come more devastating. And any issues about coming for the flooding and so on and so forth also extremely dangerous for our situations. My question is about the population issues between India and Indonesia. Maybe you can share with us your experience, how to manage this situation in terms of the booming populations, number one. And number two is about how you engage with the people in terms of running these projects. I think it will be very excellent samples, explanations from both projects, India and Indonesia. Thank you very much.
Thank you. Professor August, you want to go first or you want me to go first?
I want you to go first.
Okay, okay. Sure. So I think, Mr. Ahmed, you really pointed out very important aspect of the waters management because population impacts the water use, and more population means more urbanization. So more roads, more buildings, hard surfaces, and that increases surface runoff and less groundwater recharge. So it really changes the hydrologic cycle. And then once the hydrologic cycle is changed, then we have more issues. So it's a very complex thing because when you build more houses, and then you have this urban heat idle effect. So there's a temperature difference than what it used to be before. So I can tell you, only a month ago, I was in India in my village, and I remember 30, 40 years ago, even temperature might be 40, 45, still was comfortable living in the house. And this time, say similar temperature, but very hot because of this urban, many houses used to be mud houses and lot of trees and so on. Now they have gone and more concrete houses, roads. And so even in villages, there is a urbanization effect, similar urbanization effect. And so uh, that's a big challenge. Now, how do we do this? So I think we can't deny uh, building more houses because we have to make people live. And but we need to design more water sensitive houses, more climate sensitive suburbs. So where we have trees, we have porous grounds where groundwater can be recharged and less flood effects, and also rainwater can be managed more effectively. So we need to change the way we design our population habitats and cities and villages and so on. And in terms of the second part of the question is how do you engage community? So it is not 1 month or 1 day or just few meetings and it will work. Actually, you have to allow quite a good amount of time. You have to start with a good faith. Okay, I want to change this and I want to work with people. And again, working with people is you have to be part of them, not you tell and go, okay, you do this and I know everything and I have the funds to do. It won't work. But they have to be part of, you have to be part of them. And then you engage, you provide training, you provide tools, you provide opportunities, and give respect to the community, and they will be part. And I think at the end you will see the change without any doubt. So engagement is a long term, and you have to have patience, and you have to work with them. You have to empower them with the knowledge, science, whatever is required, and also help them facilitate where to find the resources. Many times it's not the fundings, but how to really work together. So this is my sort of last 10, 15 years of learning, working with the community. And Professor August have equally or even better experience than me.
Thank you, Mr. President. You are also.
Okay, we give the opportunity for Prof. Agus to answer the question from Mr. Ahmad.
Yeah, actually the answer is very important. Professor Ahmad Agustiawan is my friend, my best friend. He was in Australia to know well about Australia and Indonesia. That way, they ask us about the situation. All of movement is actually for all of people. So the climate change and its impact seem to be not possible to solve using a program, government program, because the impact of climate change is running very fast. The only thing that we can do is a movement, is a work of all people, of all individual, in terms of individual work activity or group or collection. So that way, so that movement is building a trust each other and building a motivation each other, a building of understanding each other, and building innovation each other in terms of mitigation and adaptation of the impact of climate change. So I think group of people like community is one of very important thing to distribute knowledge to the people around themselves. And nowadays we have already networking using IT to touch every community, even in the other globe, yeah, in the other area. We can touch them and we can feed them with understanding, with knowledge and so on. And they can also feed us with knowledge, real knowledge or local wisdom and so on. So then we, using that kind of movement, connecting between community, then the development or the mitigation adaptation to climate change will be also effective compared to program of the government. I'm not denying the program of government. I suggest to the government, local government, also national government, to change a little bit, maybe 50%, so not in the projects, but the project of community movement. So the budget of the projects shifting the community movement. And in the long run, the community will understand, they will understand how to solve the problem, and they can then solve their problem by themselves, like water or another problem that they have. So something like that. I think the situation in India and in Indonesia is a little bit different. But if we back to our history, the Indonesian people has Hindus and Buddhists, and Hindus and Buddhists in India maybe a little bit similar with Hindus and Buddhists in Indonesia. Even we are now 85% Muslim. I think the current culture is not too far with Indian culture, isn't it, Professor Basan? It's
Exactly, yeah.
Okay. Thank you,
And I
Ahmad.
think you still have Ramayana and all those things.
Yeah, Ramayana and so on. Yeah, Bharata Yuddha.
Yeah, that's right.
I'm so sorry, Prof. Ahmad. Maybe it's not satisfied for you, my answer. Thank you.
Thank you very much, Mr. Ahmad Agus Setiawan, for the question. Do you still have any question for the speakers?
It's very clear from Pak
Okay.
Agus Mariono and Pak Basan.
Thank you.
Okay.
Muhammad.
Thank you very much. Okay, so Bapak Ibu, ladies and gentlemen, it's already 11 o'clock in Jakarta, so it's time for us to end our webinar. I'm so sorry I cannot give more question to our excellent speakers because of the time limited. And so today, before we stop our meeting, it's better for us to capture the moment. So I would like to ask all of the participants to open the camera to give the best smile today, because I would like to make a documentation for this webinar. Okay. Okay. Thank you very much. Okay, maybe for the rest, I'm still waiting for 15 seconds. Here I have my lecturer, Prof. Hernani. Selamat pagi, Ibu. And also Ibu Wiwi, selamat pagi Ibu. All right, maybe it's